Welcome back to the deep dive. I was sitting at my desk this morning, coffee in hand, firing up my computer, and I had this specific thought about workspaces.
Okay.
Not the physical kind, not my desk or my chair, but the digital ones. And specifically, for anyone who writes code or works in tech, you know that moment when you open your code editor.
It's a very distinct ritual, isn't it?
It really is. The screen goes dark mode, the cursor starts blinking, and you get all the syntax highlighting with those pretty colors. It feels, I don't know, quiet.
It's a sanctuary.
Exactly, like a sanctuary. It's your workbench, you're the creator, and these are just your tools. You don't expect the hammer to suddenly turn around and, bite your hand.
That is a very evocative image. The workbench biting the hand. And, frankly, given the intelligence report we're looking at today, it is not far off from the reality.
Oh.
In fact, it might be an understatement.
That is not the comforting start I was hoping for,
Yeah.
but it's exactly why we're here. We're unpacking a report from Cybersecurity News dated January 21st, 2026. And it focuses on a tool that, let's be honest, defines modern coding for millions of people. Microsoft Visual Studio Code, or VS Code.
It is the absolute gold standard. I don't think people realize just how ubiquitous it is. From, students learning Python to senior architects at major banks, everyone is using VS Code.
And that popularity is exactly why it has a target on its back. But here's the hook, and this is the part that really messed with my head when I was reading the brief. This isn't a bug.
No.
This isn't Microsoft messing up and leaving a digital window unlocked. The software is working exactly as it was designed to work.
Precisely. This is what we call feature abuse.
Yeah.
The attackers aren't breaking the tool. They're using its most helpful features against the user.
So we have a campaign here called Contagious Interview, which, by the way, sounds like a straight-to-DVD horror movie from the early 2000s.
It does, but it's an incredibly accurate name. It refers to the viral nature of the attack and the specific lure they're using, job interviews.
And the people behind this, we aren't talking about a couple of teenagers in a basement seeing what they can break.
No. The attribution in the report points directly to threat actors linked to North Korea. These are state-sponsored, sophisticated groups. And what's fascinating here is the shift in their strategy. They've really changed the game.
Let's talk about that evolution, because the report mentions this isn't their first time targeting the tech sector. They've been after crypto developers and tech companies for years, but they used to do it differently, right?
They did. If you look back at the last few years, the North Korean playbook relied heavily on something we call click-fix tactics.
Click-fix? It sounds catchy. What does that actually look like?
It's essentially social engineering that happens outside of your coding environment. Imagine you're on a video call or trying to join a conference and suddenly you get an error message. Audio driver missing or video codec unsupported. And right there, conveniently, is a link. Click here to fix.
The classic panic click. I need this to work right now, so I'll click whatever you tell me to.
Exactly. It exploits urgency. You download a patch, or what you think is a patch, but it's actually a malicious executable file. But here's the problem for the attackers. Developers have gotten smart.
We're paranoid. If I see a weird .exe file or a random link in an email, my alarm bells go off. I'm not clicking that.
Right. The security hygiene regarding emails and random downloads has improved. The attackers hit a wall. So they realized that while developers don't trust email attachments, they have implicit, almost blind trust in something else.
Code repositories.
Exactly. You might scrutinize an email from a stranger, but if someone sends you a GitHub link, what do?
I clone it. It's muscle memory. Git clone. It's the first step of everything.
And that is the genius of the Contagious Interview campaign. They moved the attack from the browser to the terminal. They moved it inside the workflow.
So let's play this out. I want to understand the trap. I'm a developer. Maybe I'm looking for a job, which, let's be honest, is a stressful, vulnerable position to be in.
It is, and they exploit that vulnerability. You get approached, usually on a professional networking site like LinkedIn. The recruiter looks legit. The company often spoofs a real startup, usually in crypto or tech. They say, "We love your profile. We want to see your skills. Here's a technical assignment."
Standard operating procedure. Here's a repo. Clone it, fix the bug, build the feature, send it back. I've done a dozen of these.
You and everyone else. And because you want the job, you aren't thinking about security. You are thinking about performance.
Right. Can I solve this algorithm? Is my code clean?
You're focused on the test, not the environment.
So I get the link. It's a standard GitHub or GitLab link. I open my terminal, I type git clone, I pull the files down to my machine. At this point, am I infected?
Not yet. The files are just sitting on your hard drive, but they're dormant. The trap is set, but it hasn't sprung. The critical moment happens when you open that folder in VS Code.
Okay, so I launch the editor, I go to File Open Folder, I select the interview project. Now, usually VS Code has a safety mechanism here.
Yep. It does. The trust dialog, it's that big blue box that pops up and asks, do you trust the authors of the files in this folder?
And I'm going to be honest with you, and I feel like I'm confessing a sin here. I almost never read that box. I just hit yes.
You are not alone. It's what we call alert fatigue, or just pure muscle memory.
Right.
Because if you click no, VS Code goes into restricted mode.
Right.
You can't run code, your extensions stop working, the debugger is disabled. If you were trying to take a coding test, restricted mode is useless.
So the tool basically bullies you into saying yes if you want to get any work done.
In a way, yes. And the attackers know this. They know that 99% of developers will click yes, I trust the authors, within a second of seeing that box. And that click, that is the trigger.
That's the detonator.
That is the detonator. Because the moment you grant trust, VS Code automatically scans the folder for configuration files. And in this campaign, they are abusing a specific file called tasks.json.
Let's unpack tasks.json. Because I use this file, I use it for legitimate stuff. It's for automation, right?
Right, exactly. It's a convenience feature. Let's say you have a complex build command. You don't want to type it out every single time.
Sure.
So you put it in tasks.json. Then, VS Code can run it automatically when you open the project or when you hit a specific shortcut. It's designed to save you time.
But in this context, automation just means automatic execution of commands.
That's it. If you can write a script to compile a program, you can write a script to download a virus. And because you clicked trust, you have authorized VS Code to run those scripts without asking you again.
That is sneaky. So what actually happens? Does a terminal window pop up with skull and crossbones?
No, silence is key here. The Jamf researchers, who are the ones cited in this report, they found that the malicious commands are configured to run in the background.
Okay.
You're looking at the readme file, trying to figure out the interview question. And meanwhile, underneath the surface, a shell command is executing.
So while I'm stressing about reversing a binary tree, my computer is getting owned.
Completely owned. And the technical details of how it executes are really interesting, especially for anyone on Mac OS. The report breaks down a specific command structure using NoHup and curl.
Okay, let's translate for the listeners who haven't spent 5 years in a Linux terminal. Curl is for downloading, right?
Yes. Curl grabs data from the internet. But NoHup is the dangerous part here. It stands for no hang-up.
No hang-up.
In a Unix-based system like Mac OS or Linux, usually if you close the terminal window, any process running inside it gets killed. The system cleans it up. NoHup tells the system, ignore the terminate signal. Keep this running even if the user closes the window, even if they log out of the shell.
It creates a zombie.
A zombie that is very much alive. It detaches the malicious process from VS Code. So the task.json triggers this command. The command uses curl to reach out to the web and download the payload, the actual malware.
And where are they downloading it from? Some shady dark web server?
This is the other brilliant part of the evasion. They are hosting the malware on Vercel.
Vercel. I use Vercel. I host my blog on Vercel. Half the tech industry uses it for their front-end hosting. It's a totally legitimate platform.
Which is exactly why they use it. Think about a corporate firewall. It blocks traffic to known gambling sites, known malware IPs, maybe even geo-blocks certain countries, but it is never going to block Vercel. If a company blocked Vercel, their developers couldn't do their jobs.
It just blends in. It looks like normal developer traffic.
Hiding in plain sight, so the firewall lets it through, the payload downloads, and then it executes directly in the Node.js runtime.
Node.js, that's the engine that runs JavaScript outside the browser. And since VS Code is built on web tech, Node is always there.
It is. But remember the NoHup command. This is the detail that keeps me up at night. Because of that command, the malware process runs independently of VS Code.
Wait, so if I finish the interview, or even if I get suspicious and quit the app,
the malware keeps running.
Closing the window doesn't stop it.
No. You can quit VS Code, you can force quit it, you can drag the icon to the trash. The malware is running as a separate process in the background memory of your operating system. It has successfully jumped from the application layer to the system layer.
That is persistent. That is the definition of a nightmare scenario. You think you've closed the door, but the intruder is already in the attic.
And this intruder starts making phone calls immediately. The report identifies a specific IP address, 87.236.177.93. This is the command and control server, the C2.
The C2, the mothership.
Right. The malware establishes a connection, and it begins beaconing. It sends a signal to that IP address every 5 seconds.
Every 5 seconds? That seems incredibly aggressive. Usually malware tries to be quiet, like check in once a day so nobody notices. Why every 5 seconds?
It signals intent. A 5-second beacon means they want real-time control. They want an interactive session. This isn't a smash and grab where they steal your cookies and leave. This is a tunnel.
They're sitting on the line.
Exactly. The malware enters a loop. First, it scrapes your basics. Host name, MVIC address, operating system details. It sends that up to the attackers. This is the who have we caught phase.
So they see, oh, we caught MacBook Pro Dev running Mac OS Sequoia.
Or we caught Workstation 01 inside the network of a major defense contractor. And once they know who you are, the loop allows them to send new JavaScript instructions back down to your machine.
That's the scary part. It's not just running a preset script. It's waiting for orders.
It's fully dynamic.
Yeah.
If they see you are a high-value target, they can send a custom script to scan your local network. They can look for SSH keys to access your production servers. They can search for AWS credentials in your environment variables. They can encrypt your hard drive and demand ransom.
Because it's running in Node.js on a developer machine. And let's be real, most of us run as admin. They have keys to the kingdom.
Exactly. Developers have privileged access. That's why we are targets. You hack the receptionist, you get the lunch menu. If you hack the developer, you get the product. You get the customer data. You get everything.
This is a supply chain attack, but the supply chain is the hiring process.
That is a perfect way to frame it.
So we've established that this is bad, very bad. And we've established that it's technically not a bug, so Microsoft can't just release a patch tomorrow that fixes it without breaking the actual feature.
Right. If they block tasks.json from running, they break VS Code for millions of legitimate users.
So what do we do? The report has some recommendations, right?
It does. And honestly, the solution is frustratingly analog. It's human vigilance. The primary recommendation is scrutinize tasks.json.
So before I click that blue trust button...
Before you click yes, you have to stop. You have to open the folder without trusting it and look for a hidden folder called .vscode.
And inside that folder, I'm looking for tasks.json.
Correct. And if you see it, you need to read it.
But wait, the report said the code was obfuscated? That means it looks like garbage, right? Random letters and numbers. If I see that, how do I know if it's malware or just some weird, ugly configuration file?
Context is your best friend here. Ask yourself, does this simple interview task need a complex, obfuscated build script?
If the interview is build a to-do list in React, does it need a background script that runs curl?
No, it absolutely does not. If you see complexity where there should be simplicity, that is a massive red flag. If you see commands invoking NoHup or bash or huge blocks of encoded text in a simple coding test, do not click trust, delete the folder, ghost the recruiter.
It sounds like we need to treat code repositories the way we learned to treat email attachments 10 or 15 years ago.
That is the exact mindset shift required. We spent a decade training people. Don't open the attachment unless you know the sender. We now need to train developers. Don't trust the repo unless you've read the config.
But that's hard. GitHub feels like a library. It feels like a safe place where knowledge is shared. This turns it into, I don't know, a minefield.
It treats it like a sidewalk where anyone can leave a mysterious package. You wouldn't just pick up a package on the street and bring it into your living room and open it. But we do that with code every day.
And this goes beyond just job interviews, doesn't it? I mean, I clone open source repos all the time just to test things out.
It absolutely extends to open source. The contagious interview is just one campaign. But the mechanism weaponizing tasks.json is universal. If a popular library gets hijacked, or if someone creates a malicious fork of a tool you use, the same attack vector applies.
It really challenges the whole ethos of the social coding era. The whole point was to remove friction. Clone, fork, run, collaboration at the speed of light. This security advice introduces a lot of friction.
It does, but we are reaching a point where the friction is necessary. We have to acknowledge that repository trust cannot be a muscle memory action anymore. It has to be a conscious security decision. You are the firewall.
I want to circle back to the contagious interview aspect for a moment before we close, because there's a psychological element here that is really cruel.
It is predatory.
You have people who are looking for work, the market is tough, maybe they've been laid off, they are vulnerable, they want to impress, and these attackers are weaponizing that hope.
They are. And that's why it works so well. Social engineering is always about emotion. When you are anxious to please, you lower your guard. You assume the person on the other end, the recruiter, has power over your future, so you comply. You want to show them you can follow instructions.
Clone this repo. Sure thing, boss.
Exactly. The attackers know that if they wrap the malware in a job opportunity, the victim will do the work of installing it for them. They aren't just hacking the machine, they are hacking the human desire for employment.
And let's not forget the geopolitical angle. These are North Korean actors. They are financially motivated.
Right. They're looking for crypto wallets to drain or intellectual property to sell. They are funding a regime. So the stakes of your job interview are actually global.
That is a heavy thought to carry into your next coding session. Your laptop becoming a node in a geopolitical conflict because you wanted a new job.
It's the world we live in now. Everything is connected.
So let's bring this home. I want to recap the key takeaways for the listeners just to make sure this sticks. Because if you take one thing away from this, I want it to be this.
Sure. Let's break it down.
Number 1, there is an active campaign called Contagious Interview targeting developers right now.
Correct. And it uses fake job interviews to lure you in.
Number 2, it works by tricking you into cloning a repository that contains a malicious tasks.json file.
Not the visible code.
Number 3, if you click that blue Trust Authors button, the file executes a script. It downloads malware from Vercel, runs it in Node.js, and crucially, it keeps running even if you close the editor.
A persistent background infection that beacons every 5 seconds.
And finally, number 4, the only way to stop it is to look before you leap. You have to inspect the files before you grant trust.
Scrutinize the .vscode folder. If it looks weird, work away.
It is eye-opening stuff. It definitely changes the way I'm going to look at my editor tomorrow morning. The safe space feels a little less safe, a little more exposed.
A little paranoia is a healthy thing in our line of work. It keeps you sharp.
Before we sign off, I want to leave everyone with a thought to mull over. We've built an entire industry on the idea of shared code. Don't reinvent the wheel. Stand on the shoulders of giants. We trust strangers' code every single day.
We do. It's the foundation of modern software.
But if the tools we use to share that code, the configuration files, the automation scripts, if those become the primary vector for infection, do we have to rethink how we collaborate?
It is the paradox of trust. To build big things, we have to trust each other. But to stay safe, we have to trust no one. Balancing that is going to be the defining challenge of the next decade in software development.
It's a scary thought, but a necessary one. So the next time that blue box pops up on your screen asking, do you trust this author? Don't just click it, read it, think about it.
Stay safe out there.
Thanks for listening to The Deep Dive. Stay curious, stay cautious, and please check your config files. We'll see you on the next one.